Tuesday, 15th of January 2019, paper 2H. Okay, so the first question is to do with scale models. And we have the scale of a model. So I like to write model to real. And the scale is 1 to 200, which means the real plane is 200 times the size of the model. Okay, so a plane has a length of 73 meters. That's the actual length of the plane, of course. So 73 meters I will write here. Okay, and I can easily work out the length of the model by dividing it by 200, because it's 200 times smaller. So 73 divided by 200 gives me 0.365. So 0.365. This is in meters, of course. And give your answer in centimeters. There are 100 centimeters in a meter. So you multiply this by 100 and we end up with 36.5. Next question. This arithmetic sequence is going up in 4s. So that means the formula starts off 4n. The next thing to do is to work out the term before the first term. So if it goes up in 4s, you just count back 4, and the number here is 3. So the answer to the question is 4n plus 3. Next question. There are 90 counters in a bag. Each counter is either red or blue. So what I'm going to do is first of all divide 90 counters into red and blue according to the ratio. So the ratio parts add up to make 15. If we do 90 divided by 15, that's 6. And then I can write here red to blue is 2 to 13. Okay. Each part is worth 6 counters. So times both of these numbers by 6. 2 times 6 is 12. And 13 times 6 is 78. And they obviously add up to make 90, which is good. Okay. Lee is going to put some more red counters in the bag so that the probability of taking a red counter from the bag is a third. Work out the number of red counters Lee is going to put in the bag. Right, so at the moment there are 12 red counters in the bag. Now Lee is going to add some counters in the bag. Let's call the amount of red counters that are added to the bag X. So what that means is, at the moment, the probability of choosing a red one would be 12 over 90. That's at the moment. Yep. Or you could cancel that down to 2 over 15. But Lee's going to add some red counters to the bag. So afterwards, there will be 12 plus X red counters in the bag. And that's out of a total of how many is in the bag? Well, originally there was 90 in the bag, and now there's 90 plus the amount that you've added, so X. Now this is the new probability of red, but they tell us this is equal to a third. So we set it equal to a third, and we can do some diagonal multiplying now. Okay, there's a technique that you can use when you have a fraction equal to a fraction. A over B equals C over D. A times D equals B times C. So 3 times 12 plus X, and remember not to write times, use brackets, equals 1 times 90 plus X, and 1 times 90 plus X is just 90 plus X. Expand the bracket, 36 plus 3X equals 90 plus X. Let's do a bit of rearrangement. So 3X minus X is equal to 90 minus 36. That's 2X is equal to 54, and that means X is equal to 27. So the question says, how many red counters did Lee add to the bag? Well, we called that X, and we've just figured out X is 27. Next question. Okay, draw a Venn diagram to show this. Okay, So we have two circles that overlap. I can tell that they overlap because there's an A intersection B. So let's draw two circles that overlap. Okay, label them A and B. Let's start with the middle bit first. In the middle bit, which is A intersection B, we have 1 and 3. A union B are these numbers, and A is odd numbers only. Okay, so let's have a look at A union B. That's all three parts here, but we know that A contains odd numbers only. Now I've already used the 1 and the 3, so I'm just going to cross those out and write all the other remaining odd numbers in A. So we have 5, 7, 9 and 11. Let's cross those off. 5, 7, 9 and 11. And all of these numbers will be in A union B, so that means the remaining ones must be in B on the right hand side here. So we've got 2, 4, 6 and 12. And then if you check the numbers in the list against the numbers that we've used already, you will find that the only numbers that we haven't used are 8 and 10. So they need to go outside the circles but inside the box. Okay, work out the area of the shaded rectangle. So, a bit of problem solving here. Let's draw one of these rectangles out and use a bit of algebra to help us. Okay, we'll call the long side X and the short side Y. So at the bottom of this shape you can see that we have 4 X's here and 1 Y. So we know that 4x plus 1y is equal to 123 according to the diagram. Along the side here, the left hand side, we have an x here and an x here and then also a y at the top. So we can see that 2x plus 1y is equal to 67. And we can use simultaneous equations to solve this. Okay, by subtracting we have the same number of y's there. So if we subtract, we get 2x is equal to, let's have a look, 2x is equal to 123 minus 67, that's 56, and that means x is equal to 28. If we substitute to work out y, so we have, if we use this equation here, so we've got 2 times 28 plus y is 67, that's 56 plus y is equal to 67, okay, so that means y is 11. Now, how are we going to work out the shaded area? Well, consider it like this. We have a large rectangle there, the outer one, which is 67 times 123. 67 times 123. And also we have lots of these white rectangles. Let's see how many we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of those. So if we work out the large rectangle, then subtract 12 of the smaller rectangles, which are 28 by 11, it should leave us with the grey bit in between. So we have 67 times 123 minus 12 times 28 times 11, and that gives us 4,545 as the final answer. Okay, so the next question is to work out the highest common factor of 96 and 120. Now, you're not asked to show how you write these numbers as products of prime factors. So I would help myself a little bit and use the calculator to generate 96 and 120 as products of prime factors. So type in 96, press equals, then press shift and the fact button. So we know that 96 is 2 to the power of 5 times 3, and 120 is 2 to the power 3 times 3 times 5. Okay, so the HCF is the highest common factor. So you go through each of the factors and you look for the highest one That's common to both. So out of the 2's, the highest power of 2 that's common is 2 cubed. Out of the 3's, the highest power of 3 that's common is just 3. So 2 cubed is 8, 8 times 3 is 24. For the next one, they're already written as products of prime factors, quite handy. For the LCM, it's quite straightforward. You choose the highest power of each different prime factor, and the great thing is it doesn't need to be common. So out of the 2's, despite the fact that 2 is not included in C, you can still use the highest one there, which is 2 to the power of 4. Out of the 3's, it's just 3. Out of the 5's, it's 5 squared. Out of the 7's, 7 squared. And out of the 11's, 11. Now, it's up to you whether you leave it like this or whether you work it out. They don't mind, but if you work it out, evaluate it, it's 646,800. Compound interest. So, we use the formula, which is the initial value, okay, the initial investment amount, 8,500, times the multiplier, which is 1 plus x over 100, so 1 plus 2.3 over 100, to the power of the number of years. So it's in there for 3 years, and this is what we type in the calculator. Okay, so let's have a go. 8,500 times brackets 1 plus 2.3 over 100 to the power of 3. Okay, 9,100. Give our answer to the nearest dollar. So to the nearest dollar, that's 9,100. Rami bought a house on the 1st of January 2015. It increased in value by 15%. Okay, so that's 1 plus 15 over 100 as a multiplier, which turns out to be 1.15. In 2016, the house decreased in value by 8%. That means 1 minus 8 over 100, which is 0.92. Okay. On the 1st of January 2017, the value of the house was $687,700. What was it? Okay, so we've got the 2015 value, and then it goes up by 15%, so times by 1.15, and then it goes down by 8%, so you times by 0.92, and then that gives us the 2017 value, which is $687,700. We're trying to work out the 2015 value, so we just go backwards and divide. So we have $687,700. We divide that by 0.92, and then we divide that by 1.15, and that gives us $650,000 in 2015. Okay, we just write down what we did there: 687,700 divided by 0.92. But I check this. 687. Okay, 747. 500. Okay, and then we divided that one by 1.15. Okay, to give us the answer to the question. So on the answer line, just make sure you do write it on the answer line. Okay, next. So density, recall the formula for density, goes like this: DMV. We say don't move Vicky. Okay, work out the volume. If you're going to use one of these triangles, you cover up the one you're trying to find, so you're trying to find volume. So you do mass divided by density. So the volume is the mass, which is 3.5, divided by the density, which is 0.65. And these units are consistent. Kilograms divided by kilograms per meter cubed. Okay, Let's type this in. 3.5 divided by 0.65. This gives us an answer of 5.38. 461, etc. Okay, and we'll round it to three significant figures, 5.38. Right, the next one. Change the speed of 630 kilometers per hour to speed in meters per second. Right, so we've got 630 kilometers per hour, and what we want is meters per second. So let's do this in stages. We know, let's draw the little flow chart for meters and centimeters, etc. So there are 100 centimeters in a meter, so to change from centimeters to meters you divide by 100. There are 1000 meters in a kilometer, so to change from meters to kilometers you divide by 1000, and vice versa, you just times. So to change kilometers into meters, first of all, I'm going to times by 1000. So if I times this by 1000, I have 630,000 meters per hour. That's for 1 hour. What I'm now going to do is change this into minutes. Okay, so I'll just do it in stages. Okay, and I know that there are 60 minutes in an hour. So if I do 630,000 divided by 60, it gives me 10,500 meters per minute. And I want meters per second. To go from minutes to seconds, I divide by 60 again, and that gives me 175, which is the answer. Next question, simultaneous equations. So we need the same number of x's or the same number of y's. What we can do is we can multiply the second equation by 2, and then we'll have the same number of x's. So let's copy out the first equation. 4x plus 5y equals 4. And the second equation is now 4x minus 2y equals 18. Okay. We need to eliminate the x's or y's. Well, I've just scaled the x's up, so I'm going to eliminate the x's. How can I eliminate the x's? By subtracting, and you must write a minus here. If you do not indicate to the examiner whether you're adding or subtracting the equations, you will score 0, even if you get the right answers. So this is very, very important. So we subtract now. I like to write a minus in each section, so don't forget. 4x minus 4x, bye-bye. 5y minus 2y is 7y, and 4 minus 18 is negative 14. So y is equal to negative 14 divided by 7, which is negative 2. Okay, just substitute to work out the x now. Okay, if I use the bottom equation, I have 2x minus 2 is equal to 9. So 2x add 2 is equal to 9. So that means 2x is equal to, if I take 2 from both sides, 7, and then if I divide by 2, 3.5. So 3.5 and negative 2. Next question, find an equation for line L. Okay, so the equation of a straight line is y equals mx plus c. M is the gradient and c is the y-intercept. How to work out m? Choose 2 points on the line. We can use the triangle method or we can use the formula method. So the coordinate here is 0, 1, and this coordinate is 2, 4. Okay, we normally label the coordinates x1, y1, x2, y2. And the formula for gradient is y2 minus y1 over x2 minus x1. So m is equal to 4 minus 1, because I've labelled them here, over 2 minus 0, and if you type that into the calculator, it's 1.5, or if you like, 3 over 2. I prefer fractions. C is where the line crosses the y-axis, otherwise known as the y-intercept. We can see, S-double-E, what C is. It's 1. So the answer to the question is y equals 3 over 2x or 1.5x plus 1. Next. Right, when you have a question like this, it has to be answered in a particular way. So I like to write, you have to compare a measure of central tendency, like the median, and a measure of spread. So if we write down median and IQR, and then on the second line and the fourth line, I'm just going to write down the words explain. Because if you set it out like this, it's very hard for the examiner not to give the marks. So median. Which median is higher? So the science median is higher, and this is all about test results. So we'll write a sentence to explain that. Say, science median greater than maths median. Okay, what does that mean? Explain what does it mean? Well, this is a science test, and the median is a type of average. So on average, students performed better in science. Okay, IQR. So IQR, which I prefer to say which IQR is lower. So maths IQR is lower than science IQR. And what does that mean? When the IQR is lower, it means the data is more consistent. So maths results are more consistent, or less varied, or less spread out. But the exam board like the word consistent. Now, to get the marks, at least one of these descriptions must be in context. So I have satisfied that condition, but it's just so much easier to set it out like this. Median explain, IQR explain. Next question. Right. Even a banana to the power of 0 is 1, as long as it's in brackets. So the next one, you must remember to raise each of these terms to the power 3. 3 to the power of 3 is 27, and then we use the rule for the algebra. When you have a bracket to a power, you times the powers. You get x to the power 6, 2 times 3 is 6, and y to the power 15. The next one, factorise fully. Watch out for that word, because it's quite tempting to write this down on the answer line, and that means you have factorised it. But those of you that have a sharp mathematical eye, you will notice that the bracket is also the difference of two squares, which can be written as e minus 3 and e plus 3. Okay, make r the subject. So in order like this. It's all trapped inside a square root, so we need to square both sides initially. So if we square both sides, we get m squared equals 6a plus r over 5r, times both sides by 5r. So 5rm squared equals 6a plus r. Gather all your r's on one side. So 5rm squared minus r equals 6a. Next thing to do is to try to isolate the r. And they ask this question quite often. So be prepared to factorise to get the r on its own. 5m squared minus 1 is equal to 6a. And finally divide by that bracket, so r is on its own. 6a over 5m squared minus 1. And there you go. Next. Okay, so just this question is a little bit more complicated than usual. So just think, how would you work out the mean from a table? You would multiply all these products together, and we would divide it by the total frequency. So let's do that. Okay, when we add up all of these numbers, so let's do that, we're going to end up with something like this. So we multiply across. 5 times 4 is 20, 78, 112, this is 8x of course, and that's 54. We add all of them together. So when you add all of them together, you get 264 plus your 8x. What do we normally do now? Well, we divide this, the total of this column, by the total frequency. And the total frequency is 39 plus x. So 39 plus x. Yep. So it's the sum of this column divided by the sum of the frequency column. But they tell us that the mean is 7. This works out the mean. So the mean's equal, this is equal to 7. It's just a case of rearranging and solving now. So 264 plus 8x equals 7 multiplied by 39 plus x. And then we expand the brackets, so we have 264 plus 8x equals, what's 7 times 39? 273 plus 7x. Okay, do a bit of rearranging. So 8x minus 7x equals 273 minus 264. And then you end up with x is equal to 273 minus 264, which is 9. Now, incidentally, if you guess that the answer is 9, by trial and error, you will receive full marks as long as 9 is the only answer on the answer line. Okay, next, probability tree diagram. So, the branch has to add up to a whole one, so 0.65. The probability that Marcus wins is always 0.35, so we can fill in the branches quite easily on this one. Work out the probability that Marcus wins at least one of these 2 games of tennis. This phrase, at least one, think about it, it's different to exactly one. If it's exactly one, then he would win and not win, or not win and win. But if he wins at least one, that means he could, in theory, win both. So there's 3 options we need to work out. Or there's only one that doesn't satisfy the question. And this is the one I'm going to work out. So I'm going to work out the probability that he does not win. Right? And you might think, well, why am I doing that? And that's because I'd rather work out one branch than to work out 3 branches, because I'm a bit lazy like that. So 0.65 multiplied by 0.65 gives me this 0.4225. Okay. Why is that relevant? It's because all 4 of these options will add up to make 1. So I know I want the other 3. So if I do 1 minus that, I end up with the answer 0.5775. Next question. So the formula for the area of a trapezium is given to you on the formula sheet. It's a half brackets a plus b times h. So we'll just write that at the top here. A half brackets a plus b times h. And remember, h is the distance between a and b, and a and b are the parallel sides. So we just write it down like this. It's a half, and then it's a plus b, and we don't need to write them in brackets now, it's just a plus b, so x plus 5 plus 3x minus 2. And that's times by h, which is 2x minus 3. It's equal to the area of the trapezium. And the area of the trapezium is 133. Right, so let's simplify this bracket. X plus 3x is 4x. And 5 minus 2 is 3. So let's just write that there. Okay. Now, I don't really want to multiply by a half, you see, because if I multiply by a half, I'm going to end up with decimals here, and I'm trying to avoid that if I can. So instead what I'm going to do is, to get rid of the half on this side, I'm going to times this side by 2, because 2 times a half is a whole 1, and times this side by 2 as well, so that I can get rid of the half. And then I just end up with half times 2 is 1, and I can just, so that's disappeared now, and I can carry on over here. So that's 266, and I'm just going to multiply out these two brackets. So using whichever method that you prefer. I prefer the one that looks where the lines look like a crescent moon, although I'm not going to draw it. So 8x squared, remember 4 times 2 is not 6, 8x squared minus 12x plus 6x minus 9, and then simplify it all. So minus 12x plus 6x is minus 6x, and then you've got a minus 9 minus 266, which is minus 275, and that's equal to 0. Okay, which is the answer to the question. If you want to, on a show that question, you can write QED at the end. If you don't know what that means, Google it. Find the value of x. This is the stage where you need to use the quadratic formula, or you can factorize it. Okay, I will use the quadratic formula, but you must not use and solve this equation in part A, because if you do, you don't get the marks for part A, and you don't get the marks for part B because you've done part B's work in part A's space. So let's write it down nice and clearly. A is 8, B is negative 6, and C is negative 275. And we use the formula x equals minus b, so minus minus 6, plus minus the square root of b squared, so minus 6 squared, minus 4 times a times c. All over 2a, so 2 times 8, yep. Right, we type this into the calculator, and we end up with two answers. So I will use the mode now on this class whiz. So mode option A, polynomial, degree 2. Enter your A, B and C. A is 8, B is negative 6, and C is negative 275. Oh my god. Negative 6 and negative 275. So we have one answer which is 6.25. And another answer which is minus 5.5. Okay. I can reject that one because you cannot have a negative length, and the only answer to the question is 6.25. There is only one answer, and that's why it says in the question, find the value of x, singular. Next. Okay, so this question is to do with similarity. You have two volumes here. So the first thing to write down is this. We have length, area, volume. Length is associated with scale factor. Area is scale factor squared, and volume is scale factor cubed. So because we have two volumes here, I'm going to write scale factor cubed is equal to, I'm going to divide the bigger one by the smaller one. I always do it this way. So this cancels down hopefully to something nice. Let's have a look. So 960 over 405, that's 64 over 27. Two cube numbers, what a surprise. Okay, so I have a statement there. I'm asked to work out the surface area of A, so I need scale factor squared. Now it's hard to go from scale factor cubed to scale factor squared, but that is the one that I need. So instead what I'm going to do is I'm going to cube root to get to scale factor, and then I'm going to square it to get to scale factor squared. Now if you type in the cube root, yep, using shift and then square root, so cube root of 64 over 27, or if you want to use the original numbers 960 over 405, you end up with 4 over 3. Now you mustn't round this, you must not change it to a decimal. You then square this answer to give scale factor squared, so squared 16 over 9. Okay, keep it exact throughout the question, fractions are beautiful. Work out the surface area of A. So we're going from B to A, and A is the smaller one. So what we're going to do is when we go from the big one to the small one, we divide, not times. So if we do 928 divided by 16 over 9, and type that into the calculator, we get an answer of 522. Next question. Work out f of 5. That means replace x with 5. So 4 minus 3 times 5. 4 minus 15 is negative 11. Find the value of x that cannot be included in any domain. Well, when you have a fraction, you're not allowed to divide by 0. That's a fact in maths. So if you try this in the calculator, if you type in 1 divided by 0, it gives you a math error because it's illegal. So the denominator is not allowed to be 0. It doesn't mean x is 0 in this case, it means the denominator is not allowed to be 0. So what you do is you set the denominator equal to 0 to figure out the value of x that will make the denominator equal to 0. So add 2x to both sides, then divide by 2, and you end up with a half. If x is a half, or 0.5, that means the denominator is 0, which will cause this graph to have an asymptote, which means the graph will not exist at that point. Okay, so half is the answer. Work out fg of minus 1.5. So the first thing that you do when you have a composite function is you always do the bit on the right hand side first. So you work out g of minus 1.5 first of all, which is 1 over 1 minus 2 times negative 1.5. Okay, and you work this out. Okay, so minus 2 times minus 1.5 is positive 3, 1 plus 3 is 4, so this is a quarter. And then you work out f of a quarter. So you do f of a quarter, and it's for f it's 4 minus 3x, so it's 4 minus 3 times a quarter. And you type this into the calculator, and you end up with 3.25 as the answer. Okay, or 13 over 4 is fine as well. Next, bounds. Okay, so what I like to do first of all is just write down the lower and upper bound for each question. Okay, now just to be clear about this, how to work out the lower and upper bound, I'll go into a bit of detail here. The number, first of all, x has been rounded, or is correct to one significant figure. Now this number is in the units column. Okay, you have like this, hundreds, tens, units, then you have tenths, hundredths, etc. So the 8 is in the units column. What you do is you half the value of the column. Now the value of the units column is 1. If you half 1, that gives 0.5. So it's allowed to be 0.5 either side. 4.6 is correct to two significant figures. Two significant figures means it's in the tenths column. So as I said, you halve the value of the column. So if you halve a tenth, so 1/10 divided by 2 gives 0.05. So you add and subtract 0.05 to 4.6, and that will give you a lower bound of 4.55 and an upper bound of 4.65. The next one, it tells you quite explicitly it's correct to the nearest 10. So you halve this, which is 5, and then you add and subtract it to give 15 and 25. Calculate the lower bound of p. So we have a fraction. Yep. If you want the lowest value of a fraction, I mean, I always like to think about it as a cake, and you're sharing out the cake. That's what dividing means. So if you want everyone to have the smallest amount of cake, which is quite unusual, then you have to have a small cake to begin with, so the smallest number on the top of the fraction, but you're going to divide the cake between a large number of people. Now if that happens, if you have a small cake but you divide it between a large number of people, then everyone's going to get basically a crumb. So you want the lowest value on the top and you want the highest value in the denominator. So let's have a look then. The smallest value of A to use is 4.65. Sorry, I beg your pardon, 4.55. And then we want the largest, well, we want the highest number in the denominator. So the gap between M and X has to be as large as possible, and you can create that if you do 25 minus 7.5. Yep. Now if you type this into the calculator, the answer is 0.26. So the next question is histograms. Okay, work out an estimate for the proportion. Okay, so proportion, I'll either give my answer as a fraction or a percentage as or as a decimal at the end. We're going to write down the formula here for histograms. So we have FDFCW, which we say stands for Fern does French coursework. Fern does French coursework. You can insert a name of your choice that begins with F. But anyway, Fern does French coursework. Now what I'm going to do is I'm going to work out how many people are in each bar, and how many people is the frequency. So if you cover F in this triangle, we have FD times CW, FD times CW. So the CW is the class width. Now you've got to look at this scale very carefully, but this bar goes to 2. That's okay. Yeah, so the rest of them are okay. So the class width here is 2, and the frequency density is 2.5. So if I do 2, which is the class width, how wide it is, 0 to 2, times 2.5, I end up with 5 people in this bar, FD times CW. The next bar has a width of 3, from 2 to 5, and has a FD of 4. So if I do 3 times 4, that gives me 12. And the next one has a width of 5 but a height of 3.4. So we do 3.4 times 5, that's 17. And the next one is 5 times by 2.2, that gives me 11. And the last one there is 15 multiplied by 1, which is 15. So what I can do now is I can add all of these numbers together, and that gives me a total of 60. Yep. So there's 60 people all together in this question. Work out an estimate for the proportion of these people who waited longer than 20 minutes. So longer than 20 minutes is this section here. Yep. So how many people in this section here? Well, we know that the class width here is 10, and we know that the height of it is 1, so 10 times 1 is 10. So 10 out of the 60 people waited longer than 20 minutes to be served. If you want to cancel that down, it's a sixth. Right, next question. So we want to prove that angle CDA is equal to 2x. Now you have to give reasons for each stage. This is a nice proof, so we just have to be very careful how we set it out and set it out correctly. Now we have a tangent here, which I'll just go over. So we have a tangent, which I'll go over in red. Yep. And we have a chord in green. Now you can take, so you can work out an angle in the alternate segment here by drawing an additional line on the diagram, because we can use the alternate segment theorem, but the thing is we need 2 lines coming off the green line leading to the same point. So we have a line that goes from C to D, but we don't have a line that goes from B to D, but we can draw one on. So if we draw one on, this is angle X, okay, and that's known as the alternate segment theorem. So if we write CDB is equal to x. And why is that? That's the alternate segment theorem. Okay. Okay, there is in fact another chord that you can draw on this diagram. So from the green line, if we draw a line that goes like this from C to A, we can use the alternate segment theorem again, you see, because the angle between the tangent and the chord is x. If the green chord also leads to this angle here. So this is also x according to the alternate segment theorem. So CAB is also equal to x, and it's for the same reason. So that's fine. Yep. Now we have an isosceles triangle here because we have these two markers, so we can label this one as x. So if I write down, what's that, BCA is equal to x, and the reason there is base angles in an isosceles triangle are equal. Okay. Now, if I take a look at this triangle CAB, then the angle at the top here if I add these two together, x add x, and subtract it from 180, then that gives me 180 minus 2x for this angle here. Okay, so let's write that down. CBA equals 180 minus 2x. Okay, and the reason there is angles in a triangle add up to 180 degrees. Okay, and then finally, let's have a look. Let's just zoom out a bit so we can see what's going on. Okay, we have a cyclic quadrilateral here. So what we know is this angle here plus this one here should add up to make 180. So we need to write a little statement down. We have something like this: x plus BDA. So x plus angle BDA, which is the one I've marked in green, plus 180 minus 2x. So these two should add together to give 180. Right. So what do we have here? If we tidy this up, we have BDA. So I have x minus 2x, which is minus x. Take that to the other side, so it becomes x. Subtract 180 from both sides, so BDA equals x. Now the reason that I've used there is opposite angles in a cyclic quadrilateral add up to 180 degrees. Okay, and then finally, now that I've worked out that BDA is equal to x, then the CDA, which is all of that bit, must be equal to 2x. So I can write, therefore, CDA is equal to 2x, and that's fine. So line L and line M are perpendicular. We need to work out the gradient of line L first of all by rearranging the line into the form y equals mx plus c. 4y equals positive 6x, add 33. Divide both sides by 4. But what I'm going to do is divide individually each term by 4. So divide by 4, y, divide by 4, 6 over 4x, rather than a long fraction line over 4. And this way, I can see that the gradient is 6 over 4. So the gradient is 6 over 4, which cancels down to 3 over 2. That means the gradient of the perpendicular is minus 1 divided by 3 over 2, which is 2 over 3. Some people say you flip it and change the sign, the negative reciprocal. Oops, I've missed out minus there. So the gradient is minus 2/3. That's the gradient of the perpendicular. Now, line M is perpendicular to line L, so now I know the gradient of line M. Because it's perpendicular, it should be negative 2/3. So we can use the formula for gradient between 2 points. Set it equal to negative 2/3. So we have x1, y1, x2, y2. And the formula is y2 minus y1 over x2 minus x1 for the gradient. So we have k minus 6 over negative 4 take 5. And that's equal to negative 2/3, the perpendicular gradient. If we tidy this up a bit, we have k minus 6 over negative 9 is equal to negative 2/3. I'm trying to work out what k is. So what I can do here is I can times both sides by negative 9. So k minus 6 is equal to negative 2/3 multiplied by negative 9, because it's divided by here, you see. You can type this into the calculator, you end up with 6, and then add 6 to both sides to get rid of the negative 6, so k is equal to 12. Next question. Right. So, no measurements given here, but we do need some formulae from the formula sheet. The area of the base of the cone, which is pi r squared, to the total surface area of the cone. Now, the total surface area of the cone is the bit around the cone, which is known as the curved surface area, and the circle on its base. So this will be pi r squared, the circle on its base, plus pi rl, which is the curved bit around it, and it's equal to 3 to 8. Okay, it's fine. So some notes that you need to know. If you have two ratios that are equal to each other like this, a to b is equal to c to d, then this is also true. A over b is equal to c over d. And if that's true, then this is also true. A times d is equal to b times c. So you just got to know this for this kind of question. So if I start with the fractions, then I have pi r squared over pi r squared plus pi rl is equal to 3 to 8. Now remember, you can't cancel here pi r squared with a pi r squared, and that's because pi r squared is not a common factor. Okay, because of this plus here, that means you can't cancel it. It's got to be a common factor. What I can do now is if you look at above, I can multiply diagonally. So I can do something like this. 8 pi r squared is equal to 3 brackets this, because it's 3 times all of it. Okay, multiply out the bracket. Okay, we can do a bit of rearranging here. So take 3 pi r squared from both sides, and when you do that you end up with 5 pi r squared equals 3 pi rl. Okay, there's a pi on both sides, cancel that. There's an r on both sides, we cancel that. And what are we left with? 5r is equal to 3l. Now, I'll come back to this one in a moment. What I'm trying to do is to work out the size of angle AVB. So, at the moment, I know that the diameter, I could label it D, but what I'm going to do is I'm going to label it 2R. Now, this length is called the slanted length AV and VB, but I can work out what L is in terms of R from this statement here. So if I divide both sides by 3, then I know that 5/3 of R is equal to L, and this is quite useful, you see, because now the entire question, well, or all the sides rather, are in terms of R. And if you extract a triangle from the diagram there, triangle AVB, it will actually be quite easy to work this out. You see, we're trying to work out this angle at the top, angle AVB. All the sides are in terms of R, and this is really useful, because if they are in terms of R, it doesn't really matter what you say R is. If you allow R to be equal to 1, then this side will be 5/3 times 1, which is 5/3, and the other side, and the base will be 2. But if you say that R is 2, then the lengths are twice as long as they would be in the previous example, but the angles remain the same. So it doesn't really matter what value you set as R. So what I'm going to do is just eliminate the R's now. Bye-bye. And I'm going to try and work out the size of this angle. And I have 3 sides and 1 angle. You ask yourself the question in a non-right angled triangle: do you know a side and its opposite angle? And the answer is no, we do not know a side and its opposite angle. And if that's true, you're going to use the cosine rule. Now, the cosine rule for finding an angle is not on the formula sheet. We only have the cosine rule for finding a side. A squared equals b squared plus c squared minus 2bc cos of capital A. What I want is to rearrange this to work out an angle. Now, minus 2bc cos A is all one term. So what I'm going to do is I'm going to shift that to the left, and I'm going to shift the a squared to the I'm going to shift the minus 2bc cos A to the left and the a squared to the right. And when you do that, you end up with positive 2bc cos A on the left equals b squared plus c squared minus a squared on the right. Then if I divide by 2bc, I end up with cos of A is equal to b squared plus c squared minus a squared over 2bc. Now, in the cosine rule, b and c are the sides that sandwich the angle, but it doesn't really matter which one is b and which one is c, as long as they're either side of the angle. And that means the one opposite the angle must be a. So I can start to substitute now to work out cos of AVB, which is the angle at the top. So it's basically, so it's 5/3 squared plus 5/3 squared minus 2 squared over 2 times 5/3 times 5/3. Okay, so we'll type this into the calculator. So, slightly easier to do it like this. You type in 5/3, press equals, so that's now your ands. And what we do is we press ands squared plus ands squared minus 2 squared over 2 times ands. Remember, this is cos of ABB. It's not AVB. So to get angle ABV, you do inverse cos of that. If I write here inverse cos of the line above gives me an answer of 73.739, etc. Round it to one decimal place, 73.7. Okay, so we have question 23. ABCD is a trapezium. Now I want to draw a little sketch of the trapezium, and I'm just going to think about how to draw the sketch. I've got 2 points. I've got some information here, and it's based mainly on D. So if I start with D, let's put a little dot for D. D to A is minus 2 up 3. So let's say A is here somewhere. Minus 2 up 3. Left 2 up 3. And D to B is left 1 up 7. So left 1 up 7. So it's up here somewhere. Yep. And what do I know? That DC is 3AB. So, wow, okay. Oh my god. Right, so I'm going to start off with this question by drawing a sketch. Now, the diagram has 4 vertices, A, B, C, D, but the information is given from the point D. So if I mark D here somewhere and figure out where A is, so it's left 2 up 3, and there's no scale on here, this is just so I can see what's going on. Left 2 up 3, let's say A is there, and also DB is left 1 up 7, so left 1 up 7, so a little bit higher up. Okay, so that's D to B. Vector DC is 3AB. So if we kind of imagine on our sketch that, okay, so this is the length of AB, then DC is 3 of those. So let's kind of imagine that's 1, that's 2, and that's 3 of those. And it's got to be in the same direction as well, because they're multiples. A DC is a multiple of AB. It's got to go in the same direction because vectors are parallel. Okay, so we can just fill in the diagram now. Okay, and that looks a bit like a trapezium. So this must be C. Okay, so let's just edit the diagram slightly. To get from D to A, it's minus 2, 3. And to get from D to B, it's minus 1, 7. So that tells you that DB is not a side of the trapezium. Okay, but we'll just edit the diagram anyway. So minus 1, 7. Okay, and the question says, find the exact magnitude of BC. Okay, so vector BC. Okay, so we're trying to find a route to get from B to C. Now, what do we know? We know that DC is 3AB. So maybe we need to know this bit, because I mean, an ideal route would be to go from B to D and then D to C. But the problem is, we don't know what DC is. All we do know is that it's 3AB. But the thing is, we don't know what AB is either. So we're a bit stuck. So I guess my first job is to try and work out what vector AB is. So how do I get from A to B? Well, I can go from A to D and then go from D to B. So A to D is in the opposite direction of this vector. So instead of minus 2, 3, it's 2 minus 3. And D to B is minus 1, 7. when you add column vectors, you just add along the top and add along the bottom. So that's 4. So now I know that vector AB is 1, 4, which means vector DC must be 3 of those, which is 3, 12. This will be quite useful. And now I can work out vector BC. So vector BC goes from B to D and then D to C. So B to D is in the opposite direction of this, so it's 1 minus 7, and then DC we just worked out is 3, 12. And we add these together and we end up with 4, 5, 4, 5. And then the question asks for the magnitude of BC. And the magnitude of BC is the absolute length of the vector. So there's a formula to work out the magnitude of a vector. If you have a vector xy like this, the magnitude of the vector is the square root of x squared plus y squared. So the square root of 4 squared plus 5 squared. Now you may wish to write this as a decimal, but this word exact means leave it as a surd. So you type that into the calculator, it will come up with root 41, and that's the answer to the question.